I am JVN Dr. Surendra Kumar Srivastav from the Department of Science under the Faculty of Education and Methodology. Today we will discuss the Cauchy integral formula. If fz is analytic within and on a closed contour C, and if A is any point within C, then f of A is equal to 1 upon 2 pi I integral C fz over z minus A dz. Suppose fz is analytic within and on a closed contour C, and A is an interior point of C. We describe a circle gamma about the center z is equal to A of small radius r, such that this circle mod of z minus A is equal to r does not intersect the curve C. The function fz over z minus A is analytic in the annulus bounded by C and gamma. Then by Cauchy theorem, integral C fz over dz upon z minus A is equal to gamma fz dz over z minus A. Again integral C fz dz over z minus A is equal to gamma fz minus fa upon z minus A dz plus integral gamma fa dz upon z minus A. Now we have the continuity of fz at z is equal to A. For any epsilon is greater than 0, there exists small delta is greater than 0, such that mod of fz minus fa is less than epsilon for all mod of z minus A is less than small delta. Integral C fz dz over z minus A minus integral gamma fa dz over z minus A is equal to integral gamma fz minus fa upon z minus A dz. Now taking mod both sides, so mod of integral C fz dz over z minus A minus gamma fa dz over z minus A is less or equal to integral 0 to 2 pi mod of fz minus fa upon mod of z minus A mod of dz. Since mod of z minus A is equal to r, that is z minus A is equal to r e to the power I theta, so dz is equal to r e to the power I theta I d theta. Now mod of integral C fz dz over z minus A minus integral gamma fa dz over z minus A is less or equal to integral 0 to 2 pi epsilon upon r mod of dz. Now mod of integral C fz dz over z minus A minus integral 0 to 2 pi fa r e to the power I theta I d theta r e power I theta is less or equal to epsilon by r 2 pi r. Now integral C fz dz over z minus A minus I 2 pi fa is less or equal to 2 pi epsilon. Now taking epsilon is greater tends to 0, so mod of integral fz dz over z minus A minus 2 pi I is equal to 0, that is integral C fz dz over z minus A minus 2 pi I fa is equal to 0, so integral C fz dz over z minus A is equal to 2 pi I, that is fa is equal to 1 upon 2 pi I integral C fz dz over z minus A. Remark, if A is outside of the closed curve C, then integral C fz dz over z minus A vanishes, that is integral C fz dz over z minus A is equal to 0. For this case, Cauchy integral formula does not hold. Now we see the Morera's theorem. If fz is a continuous function in a domain D, and if for every closed contour C in domain D integral C fz dz is equal to 0, then fz is analytic within D. It is a converse of Cauchy theorem. If fz, again, if fz is analytic in a simply connected region D of the complex plane, so that there exists a function f dash z analytic in D and such that f dash z is equal to small fz for z in D. For proof, let z not be a fixed point and z is a variable point inside the domain capital D. The value of the integral z naught to z ft dt is independent of the curve joining z naught to z. Fz is equal to integral z naught to z ft dt and fz plus h is equal to integral z naught to z plus h ft dt. F of z plus h minus fz is equal to integral z naught to z plus h ft dt minus integral z naught to z ft dt is equal to integral z naught to z plus h ft dt plus z to z naught ft dt. Fz plus h minus fz is equal to integral z to z plus h ft dt. Now limit h tends to 0, fz plus h minus fz over h is equal to limit h tends to 0, 1 upon h integral z to z plus h ft dt. Again, limit h tends to 0, f of z plus h minus fz upon h is equal to limit h tends to 0 mod of 1 plus z 1 upon h integral z to z plus h ft dt minus fz. So limit h tends to 0 mod of fz plus h minus fz upon h minus fz is less or equal to limit h tends to 0 1 upon h integral z to z plus h mod of ft minus fz mod of dt is less or equal to limit h tends to 0 1 upon h epsilon integral z to z plus h mod of dt. By continuity, mod of ft minus fz is less than epsilon such that mod of t minus z is less than epsilon. So limit h tends to 0 fz plus h minus fz upon h minus fz is equal to 0. Now limit h tends to 0 f of z plus h minus fz upon h is equal to fz. So we can write capital F dash z is equal to fz. Thus derivative of fz is exists, so fz is analytic in D. Now the Cauchy inequality. If fz is a analytic within and on a circle C given by mod of z minus a is equal to capital R, and if mod of fz is less or equal to capital M for every z on C, then mod of f to the power n a is less or equal to capital M factorial n upon r to the power n. For proving, it is given that mod of z is less or equal to capital M. We know that the Cauchy integral formula for higher order derivatives f and a is equal to factorial n upon 2 pi I integral c fz dz over z minus a to the power n plus 1, where c is the circle as mod of z minus a is equal to r. Mod of f to the power n a mod of factorial n upon 2 pi I integral c fz dz over z minus a to the power n plus 1 is less or equal to factorial n upon 2 pi integral c capital M mod of dz over r to the power n plus 1. Again, which is less or equal to factorial n upon 2 pi capital M r to the power n plus 1 2 pi r. So mod of f to the power n a is less or equal to capital M factorial n upon r to the power n. Thank you.